Welcome to Study Loop.
This is the answer to Chapter 12, problem number 80 from the Smith Organic Chemistry textbook. And so this problem is asking us to look at the oxidation of an allylic alcohol with chromium trioxide, sulfuric acid, and water. And we get a product that I guess is different than the product you might expect just by looking at the starting material and the reaction conditions. And we're asked to draw a stepwise mechanism to explain this. And so I've drawn that out here. And I've shown lone pairs of electrons where they're relevant, and the arrows to show electron movement in blue. And so to start, the alcohol is going to attack the chromium metal, and one of these bonds in this double bond is going to break. And so you get to this intermediate. Oops, and I forgot to show a charge on this oxygen. So this oxygen would have a plus charge in this intermediate because it has 3 bonds. And so from there's a proton transfer. So you have a negatively charged oxygen up here with 3 lone pairs, and you have a positively charged oxygen here with 3 bonds. And so essentially that oxygen is just going to take this hydrogen from this oxygen. It's a proton transfer. That gets you to this chromate ester intermediate. And then the carbon-oxygen bond here is going to break and revert to the oxygen and reform this double bond with oxygen and chromium. And so that species will leave, and it leaves you with a carbocation here. And so down here in red, I've shown basically just the formation of an allylic cation. So an allylic alcohol, like this, when the alcohol leaves, you have this 3-carbon species with a cation and a double bond. And so what's actually happening is the positive charge is delocalized between the 3 carbons. And so what happens is this double bond will actually rearrange because remember, the more substituted a carbon is, the better it's able to stabilize a carbocation. And so this double bond will rearrange. And what ends up happening is the positive charge is on this other carbon, and the chromium oxygen species is able to attack that carbocation. So you get this intermediate here, and then a molecule of water is going to come and take a proton. The electrons from that hydrogen-carbon bond will revert to form the double bond here between this carbon and this oxygen. And then the chromium's going to take off again. And so that's how you get to your final product. And so whenever you see an alcohol next to a double bond, so an allylic alcohol, you should remember that these allylic cations are actually what's going to form. So what I've drawn down here in red. And so remember, when that happens, you may get rearrangement and get products that you wouldn't necessarily expect just from looking at the starting material and looking at, in this example, just a regular oxidation. And so that is the answer to Chapter 12, number